that you have says exploration guide, it's your explanation guide, that's the typo. Okay, so those are the questions we're going to be talking about as a class. So our first question is, what was the difference between what was left over in the lemonade and what was left in the milk? Kristen?
What was left in the lemonade was just sugar, and what was left in the milk was a new substance.
Okay, so you're correct. The substance in the bottom of the lemonade was sugar that did not mix with lemonade. But what was the substance in the milk? Did it just appear? Where did it come from? Where do you think it came from?
The two.
The milk and the water. So the substance on top of the milk, that stuff that's floating, is a new substance that is neither the lemon juice nor the milk. So what is the difference between these leftovers say about the type of change? So sugar in the bottom and that weird chunky stuff on top. What's the difference?
When was it changed?
It's okay. Think about it.
Oh.
I'll give you a little more time. David.
I'm saying that the one was chemical change, and the sugar, is that a physical change?
What do you think?
Because maybe some of it physically changed, some of it did dissolve, but then not all of it did. So yeah, it's a partial physical change.
Partial physical change. Okay, so here. This is the explanation that we're looking for. I think it matches kind of what you guys are saying. So there is a production of a new substance in the cup with the milk and the lemon juice. This means that the two liquids interact to form a solid. And this is called a precipitate. Would you guys agree that that was a solid, semi-solid substance on top of it? So here, our word wall, precipitate or precipitado in Spanish. Okay. So now, switching gears, what was different about the color change in the cups and the color change in the paper that was put to the flame? Do you think that you can reverse either change? Tyler, do you think you can reverse either change?
I think you can reverse the lemonade and sugar. You just have to pull the sugar out of the bottom and you dry it out. I don't think you can reverse the milk and lemon juice.
So, the color change, our explanation, what we're looking for, the color change took place in the cup was due to the temperature change in the water, but when the cup warms up, it returns to its original color. Did y'all observe that? Can you tell me what you actually wrote down for your observation for the color change in the cup? Sarah?
Wait, hang on, sorry.
So back to your exploration guide, when you were making your observations about the color changing plastic cup, what did you write down?
Oh, it's an exploration. You said it changed from blue to purple.
Okay, and then when you revisited that cup,
It changed back to blue.
back to blue. So would you say that it stayed, the color change stayed, or would you say that it was able to reverse?
It reversed back to its original state.
So if you can reverse a color change, what kind of reaction or what kind of change is taking place?
Physical change.
So the color change that occurred in the paper was after it was exposed to the flame. And we've already learned that fire is physical or chemical? Chemical. So what do you think the difference between the changes, that's about the type of changes occurring? And we covered that, talking about physical versus chemical. So let's watch this video really quickly and see an example from our lives, something we're probably pretty familiar with. It's loud. we're gonna talk about it. Okay. So, let's return to our PowerPoint. You have some questions on your explanation, guys? So what substances were interacting in the video?
Banana and oxygen.
Okay. What makes you think that?
Because this banana is
Okay. You don't think that there could be anything else happening besides banana, or you just think it's oxygen?
mixed with banana.
Okay. Then what's happening to that peel? Okay, well what happens? Can you still eat that banana if it's been sitting out for a week and it's all brown?
I wouldn't
Yeah.
want to
Put in banana bread?
If it got a little brown.
What happens when you bake banana bread though? When you bake something, what is that? Is that physical or chemical change?
Chemical.
So you would have to change it again. You have to have another chemical change to make it edible again?
Yes.
Interesting, isn't it? Was there any new matter produced? Think about that. Matter. Is there any new matter produced? Taylor?
Of the banana,
In the reaction, was there any new matter produced?
the color of the banana?
Is color matter?
No.
No. So was there any new matter produced?
No.
What would the color be? It's not matter, you're correct. So what does the color indicate?
A change in chemical change.
So, color change was the second evidence that we've observed, indirect evidence of chemical change. So, color change, or cambio de color, and it's green leaves changing to what? Dead brown leaves. Right? That happens in the fall. Maybe not so much around here, but it does happen. So, wrap up our explanation. Go ahead and look at the back, bottom portion, fill in blank questions, also true-false questions. So a color change indicates a chemical change if the color changes what? So we could reverse the cup color change, right? Because it was just reacting to the heat. But if it's an indication of a chemical change, can you reverse and make it go back to the original color? So you said irreversible. What's another word for irreversible? One word. Think of one word. Permanent. That's the word that we're looking for. Yay. Okay. So now, when we mix the lemon juice and the milk, the chunky substance that was produced was called the precipitate. Yay. Okay. So true, false. When new substance is formed from a chemical change, new matter is formed. True?
False? It's false.
How do we know that that's false?
It's not cannot be created or destroyed or molecule taken from it.
It can only what? Say that louder.
It cannot be created or destroyed. It can only go from one thing to another thing. Change.
And that would include changing the chemical composition. It could be changing form when you're talking about physical changes, right? In this case, we're talking about chemical form. So you're right, it's false. One last question. I'm going to ask you to apply some thought here. Mixing Kool-Aid and water is a blank change. Why? Jennifer?
It's a physical change.
Why is it a physical change?
Because if you let the water dry out, you're going to be left with Kool-Aid.
With Kool-Aid or Kool-Aid?
The Kool-Aid mixed, the
So-
powder.
Will you have red liquid in the container and then all the water's gone, or what will be left when all the water's gone?
Just the powder.
Just the powder. So when Kool-Aid mix turns water red or blue or whatever color it is, I like red best. When it changes color, what's causing that color to change? The color of the water.
The Kool-Aid.
The Kool-Aid. What's happening to that mix?
It's being mixed. The molecules
all vocabulary you've had before, not new information. We got this already, I promise. So yes, it is a physical change. So that was a non-example. There were some non-examples in your Explore, and we want to finish them with a non-example. Yeah. Get it? Formation. New substance.
Oh, that's perfect, and the lemonade.
Yes.
Eliminate.